Hi, so I'm Elijah the tutor, and I'm just going to demonstrate a little bit how you go about doing functions inside functions. I like to call it nested functions. I'm not sure if mathematicians call them that. Certainly in computer programming, if you have a function in a function, you would call that nested functions. So, and you'll kind of see why that makes sense in a second. If you are Key Stage 3, you might not have seen this. If you're a GCSE, depending how far along you are in GCSE, you might have seen this by now. But it seems to leave a lot of people behind, so I just want to go over it quickly. F of x equals, well, when people see that, they often get a bit confused because we're used to y equals like x plus 2. So if I said f of x equals x plus 2, you're like, okay, well, I know this bit, I'm comfortable with this, but I'm not used to seeing this stuff here. It's actually much simpler than it looks. What it means is I have a function, okay? The function's name is called whatever the letter is on the outside, and the function has a dependency on something that is inside, okay? We would call that the variable. Now, when we write y equals x plus 2, we have a function, okay? And it is dependent on a variable, which is x. And we should be familiar with that by now, because if I drew the straight line graph of y equals x squared, x plus 2, we would get this sort of graph that looks like this, right? Something like that. It's going from left to right, it's going upwards. It's not going to the origin there. It's a bit above the origin. It's actually at plus 2 above the origin, if you know your graphs well. And what we're saying is that as x varies, okay, y varies also. So if x is 1, y is 3. But if x was minus 2, y is 0. So we're saying I have a function, y, which is dependent on a variable, x, and a constant in this case, but it could be anything. So when we see these letters and then an x inside, just to remind ourselves, think of it a bit like y. Y is a function that you have been using all the time in maths, but there is nothing to stop you using other letters. You could have s equals u plus v over 2t. That's actually an equation for finding out a distance covered based on your initial speed and your final speed times by your time. But let's make it a bit simpler, because I'm just trying to demonstrate that you can have all sorts of letters other than y and x. So you could have s equals t plus 2, or you could have y equals x plus 2. And the important thing is you have a function here that is dependent on a variable here, and a function here that is dependent on a variable here. We would tend to actually we'd say this is a variable that is dependent on an independent variable. But effectively, what I'm here to tell you today is that you could also have written it like this. I have a function, and the variable that this function depends on is inside my brackets. I could say I have a function that this variable depends on, which is dependent on this variable, beg your pardon, and f function x, close brackets. So I can have many different letters to denote my functions, but what it's talking about is inside here. And I'll go one step further. If I had fx equaled, let's make it different, x plus 3, and then I wrote f1, have a think what might happen here, just for a few seconds. f1. Well, wherever in the original general equation I had, general function, I had x, which is just one place here. In that place now, instead of x, I'm going to write, just like instead of x here, there's a 1, instead of x anywhere in the equation, I'm going to write 1. And then I'm going to add the 3, and that is 4. That's saying the function which was dependent on x, when x is a very specific number, is equal to this specific number. Okay? If I had a function of f of x equals x, right, then if I had f3, that's saying x is 3. So it also, the function itself is 3, right? So that's like 3, 3. And, you know, f of x equals x. It's the same as y equals x, right? Everything is symmetric about the two axes. Whatever one thing is, the other thing is. And that was a terrible line, but you get the idea. I will add here that in real life tutoring, it is so nice because you get to ask questions and we get to interact. And I may be boring some of you, I may be going too fast for others of you, and I may have lost some of you. And when you're actually in person doing this, you can say, you've lost me, and we can think of another way of looking at this. So do want to just stress the advantages here if you need some help of doing in person or online, where it's an interactive experience. So I've talked about f of x as a function equals x plus 2 or x plus 3. I've given some examples there of that. And now I just want to talk about, well, I could have another function called g, right? A function called g that is dependent on a variable, yeah? On a variable called x. And it could be x squared, okay? It could be x squared. Or it could be 2x, and I think 2x might be a bit easier for our first introduction to this. So it could be 2x. Okay, my function g of x equals 2x. So if I plugged in a specific x value, x equals 4, I would put that inside where the x was, and then wherever x is in the equation, I put 4, and I get my 8. So you can see it's very similar to if I had y equals 2x, and I said, what does y equal when x equals 4? Most of you would be able to do that. Well, it's very similar. It's just I've got this letter on the outside and I've got this bracket, and then I put the value of x inside the brackets to say that I'm going to solve the function for a specific x value, and then you get your answer. But it's very similar to if I had y equals 2x. And my y's and my g's look quite similar. Right. Now we get to the hard part. Some of you may have followed all of this and you followed it at school, and that wasn't too difficult. The hard part is when I say I'm going to have a function f g of x. How do we even start something like that? Well, this is where I'd say the term nested function comes in a bit, because I'm going to put the f here, but instead of g of x, I'm going to take all of g of x and I'm going to put it inside. So instead of f g x, I've got f, put the brackets, and 2x. What do I need to do with this? Well, now I need to take whatever I have inside this bracket, and I need to write out this bit here, x plus 2, but I've got to be really careful. I'm not going to write x plus 2. I'm going to just write a box wherever the x was, and then plus 2. And instead of putting x here now, because I'm not looking at fx, then I put x where I've got my box, right? And then I put my plus 2. But instead I've got f2x, and I'm just going to put a box here and my plus 2, and instead of x, I'm going to write 2x. So it takes a little while to get your head around it, but that's what we're going to do. And then we're going to see, can we simplify it? Well, no, we can't actually. It's just 2x plus 2. Okay, so that's my final answer. That, in my opinion, wasn't the hardest of questions. And the next one shouldn't be too hard either, but it is a new topic potentially for quite a few of you, or one that you've just had briefly at school and didn't get on with. Let's have a look at the other way around. So if I had g, f, x, okay, I'm going to write my g, then I'm going to write my brackets, and then I'm going to take whatever was my f of x and just put it inside. And then I'm going to write out what my g of x is equal to, but wherever there is an x, I'm just going to write a box, because here I've got g of x equals 2x. But I don't have x inside my brackets anymore. I have x plus 2. So I'm going to put x plus 2 in my box. And I need to be careful because this is saying 2 times whatever is in my box, like total. Okay? So it's not going to be, some of you might have been quick and started doing it. If you did it and you said, oh, it's going to be 2x plus 2, it's not. Because it's 2 times both the x and the plus 2, okay? 2 equals 2 times x plus 2. And that's going to give me 2x plus 4. So, just to recap and tidy up a bit, I have found out, based on knowing what two functions are, what the result is if we do a function of a function this way round or this way round. I'll just clear away to get the final answers here. And that's like a good introduction to it. Obviously it will get more complicated, but I think that's quite a good introduction.